And welcome back to Engineered Coffee. Today we will dive into the second most popular capsule format in Europe, the Dolce Gusto capsule. As usual, here is where I ask for your support to please like, subscribe, and share. This helps get the channel more views and it costs nothing but makes a difference with the algorithm. This is one machine and two physics problems. In the last episode, we mapped out the capsule universe, and that's why there is no such thing as just a coffee capsule. Today, we are starting a series of deep dives into the individual formats, and we're starting with one of the most misunderstood and the most technically demanding capsule systems on the market, the Dolce Gusto. Because Dolce Gusto isn't just a coffee system, it's two completely different systems sold inside one capsule format and one machine. So, what is Dolce Gusto trying to do? Most capsule systems solve one problem. Espresso systems extract coffee under pressure. Filter systems move water through coffee. Dolce Gusto does something much harder. It must produce espresso style drinks and fully soluble drinks, coffee, milk, chocolate, instant style powders, in the same machine, with the same pump, the same user interface, and from an engineering standpoint, this is not elegant. Let's start with the coffee. Coffee does not dissolve in water. You don't mix it, you extract it. That means water must be forced through a coffee bed, resistance is required, the pressure builds, the flow must be controlled. In Dolce Gusto coffee capsules, internal pressure is very high. Filters retain the coffee. The capsule must survive pressure without leaking. The extraction must be stable and not aggressive. For coffee, Dolce Gusto behaves like a pressure-based system. Now let's start with soluble. Soluble products are a dissolution problem. Now we flip the problem. Soluble products must do the exact opposite. They must wet instantly, dissolve completely, leave zero residue, empty the capsule 100%. There's no extraction, there's very little resistance, just controlled mixing. For soluble products, just the right amount of pressure is needed. Turbulence is your friend. Flow must be open and aggressive. If anything is left behind, the capsule will fail. And here is the real challenge. Coffee wants resistance, pressure, controlled flow. Soluble products want openness, turbulence, rapid emptying. These requirements are opposite. Yet to the user, you just insert the capsule, select the volume, press start. There's no mode switch, no settings. All the complexity is hidden inside the capsule. There's a very smart design choice in the Dolce Gusto system that often goes unnoticed. Dispensing happens through the capsule itself. The beverage does not travel through internal machine plumbing. After the extraction or dissolution, the capsule is the fluid part. That means minimal cross-contamination. You can brew coffee first, then milk second, all with the same machine, without cleaning cycles in between. Milk is notoriously difficult to handle in beverage systems. Dolce Gusto solves that by keeping the product path disposable. The capsule contains the mess. Now let's talk about protection. Dolce Gusto capsules also have to protect the product from oxygen and moisture for shelf life. The original capsules start as a 7-layer extruded structure, which is then thermoformed. Those layers combine an oxygen barrier, a moisture barrier, mechanical strength, and formability, all in one body. This is true for both coffee and soluble products. At the bottom of the capsule is where things get interesting. After forming, a hole is punched into the bottom of the capsule body. Into that opening, a piercing disc is inserted, conceptually similar to the Nespresso pyramid plate. Then an aluminium foil membrane is then sealed over the disc. At rest, the capsule is fully sealed. During brewing, the pressure builds, and once the pressure reaches a defined threshold, the aluminium foil is ruptured against the piercing disc. Only then does the liquid exit the capsule. This creates a very predictable opening behavior. Interestingly, although this concept was derived from Nespresso, the logic is reversed. The Dolce Gusto capsule stays closed until pressure is high enough to force it open. There is one more problem in the Dolce Gusto format that was extremely difficult to solve, and most users never think about it. It's called dripping after use. This is especially severe with soluble capsules. And why this happens. When a soluble capsule finishes brewing, it is often completely filled with hot water or hot liquid. Unlike coffee, there's no spent coffee bed to retain the water, so when the pump stops, the pressure drops instantly, gravity takes over, and the liquid wants to keep flowing. If nothing stops it, you get dripping. Sometimes not a controlled stream at all, but a slow, messy leakage. From a user perspective, that's unacceptable. Liquid on the drip tray splashes after removing the cup, residue left behind. From an engineering perspective, it's a nightmare. So why is this harder for soluble products? Coffee capsules naturally resist dripping. The coffee bed holds the liquid, provides back pressure, acts a bit like a sponge. Soluble products don't. Once dissolved, they behave like water. That means no internal resistance, no absorption, no natural shutoff, so the capsule itself must actively manage the end of the flow. So, preventing dripping requires a very careful balance of rupture geometry, outlet size, internal volume, surface tension, and pressure decay. The capsule must open reliably under pressure, flow freely during brewing, and then stop flowing cleanly when the pump shuts off. This is not trivial. If you restrict too much, the flow suffers. The solution is incomplete. If you restrict too little, the capsule drains after brewing. There's a very narrow window where everything works. Dripping doesn't sound dramatic, but in a consumer product, it's one of the fastest ways to signal poor quality. Solving post-brew dripping is one of those problems. And that doesn't show up in lab charts, only in real kitchens. And it took a lot of iteration to get it right. This is a good example of how Dolce Gusto engineering isn't just about pressure and flow during brewing. It's also about what happens after the brewing stops. And that's where many clone systems fail. The pump stops, the pressure drops. Brewing is only half the problem. Stopping matters too. On the coffee side, there's another critical internal feature, a micro-perforated film that sits above the coffee bed. This film keeps the coffee in a relatively compressed state. That's also one of Nespresso's patents, by the way. Distributes the water evenly, prevents localized jetting, and stabilizes the pressure. It's attached to the sidewall of the capsule, about 10 millimeters below the top lid. Water enters, spreads laterally, and only then passes through the coffee. This is essential for even extraction. There's also, when the water enters the capsule, this time it's through a single hypodermic style needle. That means the top seal is under extreme stress. Internal pressures can reach up to 13.5 bar. And then there is the top lidding. The top lid is not just a simple film. It's typically a 3-layer structure, 75 to 90 micron cast or blown polypropylene for a strong bonding to the capsule, an Alox-coated PET layer for oxygen and moisture barrier, and then an additional PET layer for mechanical stability. The lid must seal reliability, survive piercing and delamination, withstand pressure, maintain the barrier properties. There is almost no margin for error. So when you look at a Dolce Gusto capsule, you're not looking at a container. You're looking at a pressure vessel, a flow control device, a barrier package, and a hygiene solution, all designed to solve two completely opposite problems inside one system. In the next episode, we'll go deeper into how these capsules behave differently, when brewing coffee versus dissolving soluble products, and why failures look very different in each case. This has been Engineered Coffee, and as I said in the beginning, please like and subscribe and share. It costs you nothing and really helps me.